All right, the next two terms, did you already find the next two terms and compare with your neighbor? Yeah? And to find the next two terms, what kind of pattern was this? Adding, subtracting, multiplying, dividing? It was just an adding pattern. We were adding how much each time? 3. So you should have noticed that each time we were adding 3. And so then that would make the next numbers 26 and 29. Yeah? We're good? Okay. So today is about adding patterns. However, they're not all that easy, right? Like that was the kind of problem you might have done in like 3rd grade. Yeah?
Yep.
It's okay because it does get harder. All right, so arithmetic sequences is the title. It's the topic of our notes as well. Arithmetic sequences. In our last unit, Unit 0, we didn't even have numbered topics yet. So this is actually our topic 1. Those are like topic A and B. So topic 1, arithmetic sequences. You can fill in the rest if you like. So down here, an arithmetic sequence is a sequence in which each term differs from the previous one by the same fixed number. We call this number the blank D. Does anybody remember what that's called from Algebra 2? So the common, and then D stands for what? Difference. Nice. Common difference. Okay. So the common difference is D, and you might be thinking, well, it's not really a difference, it's an adding pattern. What that's saying is 23 minus 20 is the same as 20 minus 17, which is the same as 17 minus 14. Okay, so anytime you subtract a number minus the one in front of it, you're always going to get the same number, and that number is your common difference. All right, what does this symbol mean right here? The arrow's going both ways. Anybody know? Another way to abbreviate this symbol is this, but that doesn't give you a lot more information. It's like the word if with an extra F. That means if and only if. So the double arrow like that means if and only if. This means if and only if. An IB class sometimes will look more complicated than a normal class just because we use some really complicated terminology here. Susanna, thanks. All right, so if you subtract a term minus the term in front of it and you get the same D, then it's an arithmetic sequence, okay? So U sub n plus 1 minus U sub n. This means the nth plus 1 term, and this means the nth term, and that still might not be helping you, so let's just do an example. If n is 4, then this would be the 5th term minus the 4th term, okay? So you just take any term, you subtract the term in front of it, and if you get the same number D, like we did up here, then it's arithmetic. For all n in the set of, who remembers what Z is? We talked about that last week. Z is a set of integers, okay? You don't have to memorize it, but you should be familiar with it. So when I tell you that Z is a set of integers, you're not surprised. Remember, integers are like positive and negative whole numbers. Okay. An arithmetic sequence can also be called an arithmetic progression because sometimes the IB uses different words. So if you see arithmetic progression, they just mean an arithmetic sequence. All right, and I told you that if you had U sub 5, that would be the 5th term. So U sub 1 is the what term? It's the first term, yeah. U sub 1 is just the first term. So here we have a general term, U sub n. If I wanted to know, for example, what the 50th term is, I don't want to have to add 3 49 times. And I would like a shortcut. So here's my shortcut. Take the first term, and you are going to subtract 1 from the term you want. So If I wanted the 50th term, I would multiply 49 times the d. And we're going to get practice doing that in just a minute. I want to give you 30 seconds to process, and then we're going to look at these problems down here. Feel free to work ahead. Can you lock the door, please? Thanks. Feel free to work ahead, but also feel free to take this time to process about another 20 seconds. And 30 minus 23. Do they give us the same answer, all of them? Yeah. They all equal 7. Therefore, 3 dots means therefore, the sequence is arithmetic. You can write out therefore. Okay. Because 7 is our common difference. The next one says find a formula for the general term u sub n, and I am going to let you try to find that real quick, but let's just go over what we know. We know that d equals 7, and we also know that u sub 1 equals what number? U sub 1 is our first term, so what's our first term? 2. Good. So we know these two things, and we have this equation here. So let's substitute in and see what we can come up with. Okay, so most of you realize we don't know u sub n, so u sub n stays a variable. For u sub 1, we substitute 2. We don't know n, that stays a variable. And we do know that d is 7. They don't put a parentheses on d, but I do, because when your d is negative, it looks like you're subtracting it instead of multiplying by a negative number. So I usually put parentheses on this d here. And then we need to simplify it. So to simplify it, I'm going to start by distributing the 7 to the n and the minus 1. And there's one more step I can do to simplify, which is what? Yeah. So 2 minus 7 gives me negative 5, so I have u sub n equals 7n minus 5. This one that some of you wrote is good. It's just not completely simplified. You can simplify it as much as this. So then if you want to find the 100th term, the 100th term is u sub 100. So this is the name of the 100th term. So notice that where the n is, we're putting 100. So we're also going to put 100 here. U sub 100 equals 7 times 100 minus 7. All right, and oh, I said minus 7, right? What did I do wrong? Typo, right? Should be minus 5. I just made a typo. So 695. All right, I want you to take a minute to consider this question. This is a good question to think about. Are these numbers terms in the sequence? So I know, for example, that 2 is a term, 9 is a term, 16 is a term, 23 is a term, 30 is a term, 695 is a term, but I want to know if these are terms, okay? So take a moment and think about how you can do that without having to just keep adding 7 each time. So check to see if 828 can be an answer. I'm going to put it equal to the 7n minus 5. And I'm going to add 5. 833 equals 7n. And then divide it. And then you guys got n equals 119, correct? Okay. Excellent. So that means this is the 119th term. 119th term. All right, did anybody use that method to check and see if this was a term? Same method? So the same method works. Was it a term? No, because we didn't get what kind of number? We didn't get a whole number or an integer, right? We would expect to get an integer there if it were a term. I'll show you what that looks like. Did anybody use guess and check on this one? Right? So you might have guessed the number, you might have guessed like 335 and realized it was too low. And then you guessed 336 and it was too high. And then you realize there's nothing there. So it's not 1. So guess and check can also work. So let's use our algebra though. 2, 3, 4, 1 equals 7n minus 5. 2, 3, 4, 6. And we divide it by 7. And I'm getting 335.14. Anybody else get that? 335.14. So when you're talking about terms, there's no fraction term. You can have the first term, the second term, the third term. You can have the 512th term, but you can't have 512.5 term, okay? So if I'm getting 335.114, that means that this number is not a term. Because we need n to be an integer. Any questions? Okay, let's give people 30 seconds to process that. If you're done though, you may turn the page. Okay, so let me turn the page. So it says given that these are consecutive terms of an arithmetic sequence. So we're given an expression, 3k plus 1, k, and negative 3. These are consecutive terms of the arithmetic sequence. If they're consecutive terms, it means that if you subtract the 1 minus the 1 in front of it, you're going to get a common what? Common difference. Good. So the second term minus the first term should give you the same common difference as the third minus the second. Okay? So you should get the same common difference if you do the second minus the first as if when you do the third minus the second. So we can do the second, k, minus, I'm going to put this in parentheses, 3k plus 1. I'm not going to put d there because there's no need to introduce another variable. Okay, second minus first is the same as third minus second. So third minus second. So once you think about how to set it up, all you have to do is solve it. Take a minute to solve that and see if you get the same answer as your neighbor. And feel free to work ahead with number 3 if you're ready to. Okay, I hear some good explaining, so I will explain up here, but if your neighbor's explaining, feel free to listen to them too. Distribute your minus. So the minus distributes, so minus 3k minus 1. I'm going to combine these 2k values first. So 1k minus 3k should give you a negative 2k. And then you want to get your k terms on one side and your constant terms on the other side. So I'm going to just rewrite this up here so I have some room to work. Negative 2k minus 1 equals negative 3 minus k. I'm going to add 2k. You really had a choice. You could have added the 1k or added the 2k. It doesn't matter. But by doing this, I'm going to end up with a positive k on this side. So since I'm moving the k's to the right, I'm going to move that 3 over here. So to get rid of the minus 3, I'll add 3. So this cancels. This gives me 2. This cancels, and this gives me 1k. Questions? I am recording this, so I understand that we all process at different speeds. And if it's going too fast for you, just go home and watch the videos so that you can take time to process all of that. For number 3, I think a really good way to set this up so that you can start thinking about it is just with spaces. So insert 4 numbers between 3 and 12, so all 6 are an arithmetic sequence. So we have 3, space, 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 12. And we're trying to figure out what these numbers in here are. And pretty quickly, with trial and error, you'll realize that they can't be integers. There's no way to make them integers so that it will work out. So we still have to figure out what number they are, okay? So take a little bit of time to think through that. So let's take a look here. We start with what number? What's your first number? 3. It's an adding pattern, so I'm going to have to add something to it, right? We don't know what number we're adding. That would be helpful if we knew what number we're adding. How many times do we add to get from the 3 to the 12?
4.
It looks like 4. It's so tricky. Let's look. To get from 3 to here, yep, because this is 1, 2, 3, 4, and then the last one gets you to the 12, right? So we're adding 5 times. We don't know what we're adding, but we have a variable for it. It's D. So we're adding D 5 times. We're adding 5 D's. Okay, so starting at 3, if you add 5 D's, you end at what number? 12. At 12, good. Okay. And if we solve this, we can find D. Is it 1.8? Yes. Okay. All right. So back on the first page, remember we said n couldn't be a decimal because you couldn't have like a 1.8 term, but D can be a decimal. You can add 1.8 each time, okay? N cannot be a decimal, D can be a decimal. So now let's go ahead and add 1.8 to get those numbers. Okay, so I added 1.8. Through it, but here's some of the first stuff. I saw a lot of you had this. Notice the notation, u sub 1 equals, that's your first term, and that was your first term. All right, each week it's 3 more, so you can just add 3. If you used a formula though, that's great. It's good practice to use a formula. All right, so each week we're just adding 3 more. All right, then it asks a really weird question. First it says create an arithmetic sequence, and then it says show that it's an arithmetic sequence. So you're not usually going to do both of those things in the same problem, but it's good practice. So to show that it's arithmetic, you're just going to subtract them and show that they're all 3. So 37 minus 34, and then 34 minus 31, and then 31 minus 28. They all equal 3. Which is your D, and so therefore it's arithmetic. Okay, so to show that you have an arithmetic sequence, you just need to show that every time you subtract a term minus the one in front of it, you're going to get the same common difference. Now, when you take a test, and the date of your test is actually in Schoology. It's not soon, but if you want to know when it is, it's in Schoology. When you take a test, you'll be given a formula booklet like this one that I gave you. Kenzie, did you get one of these yet? Formula book? Yeah, okay. So it's always good to know where these formulas are in here because I'm not going to print the formula next to the problem on the test. You have to find it. All right, so here, if I want to find the number of the comic strips after 15 weeks, I'm going to be using find the nth term of an arithmetic sequence. So I'm going to be using this formula at the top of page 3 in your formula book. All right, so it's always good to know where they are so you're ready for your test. So I'm going to write the formula first. And then I'll substitute in. So I'm trying to find the 15th term. U sub 1 is still 28. plus 15 minus 1 times d, which is 3. All right, and you can use a calculator to find that answer, or you can do it step by step, but either way, you should get 70 comic strips. All right, so when does he send his 120th comic strip? So we want to know when the answer is going to be 120. And it doesn't work out exactly, right? But it's not like he's going to skip over sending his 120th comic strip. He does send it at some point. It's just that he sends multiple each week. So I'm going to set 120 equal to 28 plus n minus 1 times 3. And I'm going to distribute this. And this is not the only way to solve this. Combining like terms. And then solving for n. 95 equals 3n. All right, and n is equal to about 31.6 repeating. Okay, so after 31 weeks, has he reached 120 comic strips? No. 31 weeks, he didn't get that far yet. So we have to say how many weeks? 32 weeks, yeah. So 31, he had not reached it. So we have to say the 32nd week.
Wait, why didn't you reach it by the 31st week?
In the 31st week, if you substitute 31 in, we're not going to get all the way up to 120. It's pretty close, but it's not there yet. So you have to wait until you get past 120. Okay. When you're done with that, turn the page. We have a few words to write in. We're going to look at sigma notation. It's just another way of writing. It's just another notation. Okay, I'm going to turn it. Okay, a series is the sum of the terms of a sequence. So a series is the sum of the terms of a sequence. For a finite sequence, finite is the opposite of what? Infinite. Finite is the opposite of infinite. So whenever you get stuck on the word finite, just remember, oh yeah, it means not infinite. So infinite means it doesn't end. Finite means it does end. All right, so when I'm talking about a finite sequence, I mean a sequence of numbers that has an end. So I wrote series and then I wrote finite. Then the sum will also be a finite real number. For an infinite sequence, the corresponding series is, so you just see you add up all the terms. In many cases, the sum of an infinite series cannot be calculated because it's also infinite, right? So if I tell you, like, you have the series, you have a sequence of numbers, like 1, 3, 5, 7, and it goes for infinity, and I want you to find the sum of that, well, like, it's going to go to infinity, right? But sometimes the sum of an infinite series is actually finite. And so it converges to a finite number. And that usually has to do with fractions. Okay, and then this next part actually has nothing to do with that idea. We'll get to infinite series. When we get to them, we'll look at the formula and see how it works. This is just telling you that if you have a summation and this is itself a sum, you can break it into two pieces. That's convenient. This one says if you have a summation and there's some constant c here in front of the term, you can take that constant and put it in front. So these are just telling you some things you can do to break up a summation, but I wouldn't worry about those too much yet. All right, for number 5, I want you first to figure out what is the pattern here. What would be the next term? Talk to your group about what pattern you see here. All right. I hear a lot of you noticing patterns and how much you would add each time. But does it have another pattern besides that? Because an arithmetic sequence or an arithmetic series is always adding the same amount each time. And this is not the same amount, right? So what is special about these numbers? They're all special numbers. What do you think, Juliana? What's special about them? Juliana says they're perfect squares. Is she right? Yes, they are. Very good. They're perfect squares. So what would be the next one? Next perfect square? 36, right? We got 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared would be 36. So u sub 1 is 1 squared, which is 1. U sub 2, 2 squared, which is 2. You get the idea, right? All right, so this number here, 1, 2, 3, these are the n's. So we're looking at a pattern of n squared. What does the s mean here? It's a sum, right? So to show the sum with sigma notation, we put a sigma in front here. And we start at the bottom, where for some reason we use k. K equals 1, and we go up to n. All right? So if I wanted to add these all up, I would start with 1 squared, which is 1. And I would go up to the last term, say n is 6, so it would be 6 squared, which is 36. And then I would just add up all those answers. This does not follow an arithmetic pattern. It also doesn't follow a geometric pattern, which is what we're doing next time. But we're just interpreting the sigma notation here. Like, how do you write sigma notation? The next one, it does seem like it follows an arithmetic pattern. This is a pretty easy pattern, right? 1, 2, 3, 4, 5. What comes next? 6. Yeah, that's a good pattern, right? And so, u sub 1 is 1. S sub 1, that's the sum of the first term. It's still just 1, right? S sub 2 is going to be the sum of the first and the second, so that would be 3. S sub 3 is the sum of the first 3, so 1, 2, 3, that's 6. Okay? And it says to find S sub n, but actually my answer key is not giving me S sub n. So let's think about that for a minute. We want to add all these terms, right? So you're going to write this, sigma. And we want to add from the first term to n. And the number that we're adding is the same as n, right? Like u sub 1 is 1, right? U sub 2 is 2. So the number that we're adding is equal to n. So it's this simple. Okay? So from 1 to n, just add up that number. So add 1. If you want the third, you add 1 plus 2 plus 3. If you want the 10th, you add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. We are not using formulas for these summations. We're just understanding them. So for this one, we're going to expand and evaluate. So we're going to substitute all the numbers from 1 to 5 in, and then we're going to add them up. That's it. So I have 1 over 2 to the 1, 1 over 2 to the 2, Just that. I suggest you use a calculator because you're getting all different denominators here. And with different denominators, you would have to find a common denominator between all 5 terms. It's not hard, it's just a little bit tedious. So I do suggest that you use a calculator on this. Take advantage of this course being calculator based. And then when you get your answer, remember you can go math, fraction, and it will change your decimal answer to a fraction. I probably confused some of you by saying 2 squared equals 2. That's not true, right? 2 squared equals 4, 3 squared equals 9. Sorry about that. It is confusing when your teacher makes basic math errors. This answer you should have gotten 31 over 32. Yeah? All right, so just take a moment, make sure that your neighbor knows that 2 squared equals 4, not 2 squared equals 2, and 3 squared equals 9. Take a look, make sure they paid attention there. And then this answer, you should get 31 over 32. If you're having trouble using the calculator, let me know. I'm happy to help. Turn the page when you're ready. Okay, an arithmetic series. An arithmetic series is the sum of an arithmetic sequence, right? So if I gave you an adding pattern like 1, 3, 5, 7, 9, right? That's a sequence. The series is if I said, can you give me the sum of that pattern, 1, 3, 5, 7, 9. So series is when you add up all the terms, okay? And it says it right here, the sum of the terms of an arithmetic sequence. The sum of a finite arithmetic sequence with the first term u sub 1, common difference d, and last term u sub n. So in this case, u sub n is your last term, okay? Is this or this? There are 2 different formulas. The reason why there's 2 different formulas is because sometimes they don't tell you the last term. So if they don't, this formula is a little easier, right? If they tell you the last term, it's pretty easy. If they don't tell you the last term, you have 2 choices. You can use the harder formula, or you can use the a sub n formula to find the last term, and then you can use the easier formula. It's up to you. It doesn't matter. Most people just end up using the formula they have the information for, since we have 2 formulas. All right, so this one here says find the sum of 4 plus 7 plus 10 plus 13 to 50 terms. So 50 is what? Is 50 s sub n? Is it n? Is it u sub 1? Is it u sub n? What is 50? It's a good guess. Also a good guess. So u sub n is the last term, but 50 is the number of terms. So which one means the number of terms? N. So n is the number of terms, and n is 50. We know that u sub 1 equals what number? U sub 1 is your first term, and it's what number? 4. We can find d. How much is d?
3.
It is 3, because I can just do 7 minus 4 and find that d is 3. Okay? So we don't know the last term. If we don't know the last term, then we're going to use this formula. I want you to try to substitute into this formula to find the sum. All right, so to find the sum of the first 50 terms, we take n, which we found, 2 times the first term, so 2 times 4, plus n minus 1, times d, which was 3. You could put this whole thing in your calculator and get the answer at once, or you can pick it apart. That would be 25, that would be 8 plus 49 times 3. And that would be 147, and then 155. Did you guys get 25 times 155? 155. All right, and then I'll use the calculator. So 25 times 155. So I got 3,875. Any questions on that one? All right, for this one, we know the last term, right? If we know the last term, we can use the easier formula, the one on the left. We don't know n. Interesting. Find the sum. How did we do that? Oh, what? Oh, okay. We had to find n first. So find n first. To find n first, we've got to use the u sub n formula. Not the adding formula, but the u sub n formula. So we're going to go back to the u sub n formula, which I think is on the first page. Let's see. Yeah, right here in the box. My u sub n formula. I'm going to just write it down so that I don't have to keep flipping. Okay. We're going to use that to find n. I know my last term. I know my first term. I don't know n. Whoops, sorry. What is all that? Plus n minus 1. But I do know d. How much are we adding each time? 7. d equals 7. And I'm just going to solve that for n. So I have 141 equals negative 6 plus distribute 7n minus 7. 7n minus 13. And then I'll add 13 to both sides to get 154 equals 7n and divide. N equals 22. All right, that was tricky because we had our last term, but we didn't have n. So now that we have n, now we can go on and find the sum. Pretty tricky. S sub 22 is going to be 22 over 2 times the first term plus the last term. And you can use a calculator or you can think it through in your head, whatever you like. Should get 1,485. All right, we're also going to use the u sub n formula in number 9. Wait, no we're not. We're going to use the sum formula because it tells us the sum. So we're going to use the sum formula on the right. This one right up here. I'm going to write it down. We're going to substitute into it. All right, but it's going to become problematic because we're going to have two different n variables. I mean, they're the same one, but n shows up in two places. And so what we're going to end up solving is a little bit more complicated. So I'm going to give you a few minutes to substitute into that, see what you get, and see what solutions you can come up with on your calculator. All right, guys. I'm going to start substituting some things in. Some of you have really good work already, so you're way ahead of me.
Oh, okay.
First term is 8, so that'll be my u sub 1. I don't know n, so that's going to stay n.
But I get we should get there. Okay. We just distributed the 2. Yeah.
The sum was 170, so that goes here. And it doesn't, oh, it does tell me d, so d is 2. All right, so I substituted in what I know. A lot of you simplified this, so you had 170 equals n over 2, 16 plus, and then distribute the 2, 2n minus 2. And then combining like terms, you had 2n plus 14 here. Okay, so once you get to this point, what you're going to do is distribute the n over 2. So I'm going to bring the 170 over here. I have n times n. N times n is what? N squared. And then what's 2 divided by 2? Just 1. So this is 1n squared. N times n is n squared. 2 divided by 2 is 1. So I multiplied the 2 times the 1/2 here. And I multiplied the n times the n. And I get just n squared. That's the first term. Then I'm going to do the n over 2 times the 14. So 14 over 2 is how much? 7. So it gives me 7n. The 16 combined with a negative 2. 14, yeah. All right. Once we get to our quadratic equation, we have choices, got lots of choices. How do you want to solve that? Who wants to factor? Factoring is always a choice. However, in a calculator-based course, it might not be even the quickest. What would be the quickest way?
Just substitute in like x for n.
Okay, so Anne suggests change your n's to x and graph on your calculator. You can do that. And we're looking for the zeros. So the zeros, of course, are where you cross the x-axis. So you can do that too. Did anybody already factor it? You did, Sophie. Good. What did you get when you factored it?
Negative 17 and 10.
So those were your final answers, right? Your factors would be n.
2n plus 3, 4, and then n minus 7.
Oh, so you had an equation that was twice this one, right?
Yeah.
Yeah, and that's okay too. So 2n squared plus 14n minus 1 minus 340. But just to make your life easier, always try to notice that you could divide that equation by 2 and have a simpler one. But totally works what you did. That's good. All right, so I'm going to graph because that's what you guys were telling me you want to do. But if you already solved it with factoring, you don't have to graph. I'm going to clear out what's in my y equals. And like Ann said, I'm going to change my n's to x. So x squared plus 7x minus 170. All right, and my graph is not in my window. You guys see that? You could try Zoom Fit and see if it works. Sometimes it does, sometimes it doesn't. But usually what I like to do is just manually change my window. So I'm going to try Zoom Fit first and see. It's not great. So then I'm going to go to Window. I want to see more on the left and more on the right. So I'm going to change my x min to negative 30 and my x max to 30. also want to see more than just negative numbers. So I'm going to change my y max to positive, I don't care, 20. All right. So what I did is I pressed window and I'm just changing the number so I can see more of the graph. Once you do that, you press graph, and now you can find the zeros. So you go second, calculate. Choice 2 is 0. You need to move to the left of the first answer, so use your left arrow until you're to the left of the first answer. Press enter. Move to the right of the first answer and press enter. For guess, move close to the answer and press enter. So the first answer is n equals negative 17. I am recording this, so you can go back and watch this again. I'm going to find the answer on the right side now, so I'm going to go second and calculate and 0, which is choice 2. Use your right arrow to get to the other side. Okay, press enter. Move to the right. Press enter. Oh, I did something wrong. Try again. Second, calculate 0. Okay, ask for the left first, so I'm going over here. Enter. Go to the right, press enter, and then go close and press enter. So I got 10 this time. So I got n equals negative 17 and n equals 10. There are two possible answers, except can I have negative terms? No. So I'm going to keep only my positive answer because I cannot have negative terms. There are 10 terms. Okay. That was a lot.